So, conditional probability. Product rule for dependent events is this. Now, all that second part, the probability of B, and then there's a line, and then an A, that's the probability of B given that A has already occurred. So we kind of see this line, and we read it as given. So for example, if I take out a card, say I take out the Ace of Hearts first, as my first card out of 52 cards, the probability of that would be 1 out of 52. If I kept it out, the probability of me getting another ace is now 3 out of 51. Because given that I took one ace out, my sample space is now smaller, my list of favorable events is now smaller, and so my probability changes. Because normally the probability of getting an ace would be 4 out of 52. But if one of the aces has already been taken out, it becomes 3 out of 51. That's what this given thing says. So usually when we're finding two events in succession, what is the probability I get an ace of hearts and then I pull out another ace? Well, the probability of the first thing would be 1 out of 52, and then the probability of another ace after that would be 3 out of 51, because something has already occurred. Now, we get a special probability formula called Bayes' formula for calculating conditional probability, because sometimes we want to find out what is the probability of something given that something else has already occurred. If I pull out two cards and the second card I pull out is an ace, what is the probability that my first card was an ace? But I'm not telling you what my first card was. So we're looking for a condition that's already been given. So I gave you the condition that the second card I pulled out was an ace. What is the probability that my first one was? Then rearranging this formula will help us solve those. So here we've got our first example. 53 staff at a school, 36 drink tea, 18 drink coffee, and 10 drink neither. So I'm going to draw my tea circle in green. I guess it's green tea. Coffee is going to be black. We'll start putting in some numbers. 10 drink neither tea or coffee. Put that in there. 36 drink tea, 18 drink coffee. How would you like to figure this one out? This is one of those that the next number isn't given to you directly. I'll give you some time to put the numbers in. How many use this strategy? 36 drank tea, 18 drank coffee, 10 drank neither. Add those all up, and we get 64. But since there's only 53 people in total, we're over by 11. And if I count the whole tea circle, the whole coffee circle, and the outside, can you see that I added this section in the middle twice? So one way to get the next number would be to look at something like that. Okay? And then from there, you can figure out the other two sections easily because you know how many drink coffee and you know how many drink tea. So that's strategy number one. Just show of hands. How many people use that strategy? Okay. Strategy number two. You know there's 53 people in total. The entire tea circle is 36. We know that there's 10 that drink neither. It needs to add up to 53. Right now I'm at 46. I would need to add 7 more to get to 53. Now, if I think about my circles, the 36 is the entire green circle. The 10 is on the outside. The only thing that hasn't been counted is this 7 right here. And so I could have figured that out first. And if I had that 7 first, then I could get the 11 in the middle after that. How many people did something like that to start off? All right. Either way, you figure everything out here. How many drink only tea? We've got 11 here, so this would leave 25. And if we add those all up, it adds up to 53. Find the probability someone drinks tea but not coffee. Well, that is 25 out of the 53. Person is chosen at random, drinks tea but not coffee. If he is a tea drinker, so as soon as we've got this conditional given to us, all of a sudden we're not looking at the entire 53 people. How many people are we looking at? We know he's a tea drinker. We now know there's only 36 tea drinkers. It doesn't matter anything else. Doesn't matter if he likes watching hockey or if he plays croquet on the weekends. We just know that he is a tea drinker. What is the probability he drinks coffee as well? Well, there's 11 of those tea drinkers that drink coffee. 11 out of 36. So we can see this directly from our Venn diagram. The condition that's given reduces our sample space down to 36, and now it's 11 out of 36. Our formula would give that as well. If we went to our formula, and our formula says, what's the probability of drinking coffee given tea this is what our formula looks like for conditional probability. Probability of coffee and tea. Well, what is the probability of coffee and tea? That is 11 out of the out of 53 people. Out of the entire amount, 11 out of 53 people drink coffee and tea. That's our middle section. What is the probability of someone drinking tea? (36 out of 53). And if you take a fraction, divide by fraction, and multiply and simplify, you'd see that those 53s are going to cancel out, and you'll get 11 out of 36 as well. So our formula gives us the answer as well, but this one you could see it directly. Same thing with part C. If he is a tea drinker, what is the probability he does not drink coffee? Well, we're given that it is a tea drinker, so now our sample space is reduced to 36. Does not drink coffee. 25 out of the 36.